Hello students, I am Dr. Gajendra Purohit and you're watching my YouTube channel where we upload videos for engineering, mathematics and B.Sc students. I have started uploading videos on discrete mathematics and I have already uploaded many videos. If you have not seen my older videos, you can find the link in the description below or in the pinned comments. Today I'm going to tell you about finite state automata or automation. What this topic is about, and I am also going to teach a lot of different concepts in front of you here. This is an important topic. What is deterministic finite automata and non-deterministic finite automata and how do we convert it? This class is going to be a very important one. And I want to tell you that this topic is very important for computer science students. In artificial intelligence, a lot of these concepts are used from this topic. Let me show you. What's the meaning of automation? There's a small difference between automata and machine. The finite state machine has 6 tuples, whereas this has 5 tuples. We have 5 tuples, Q, summation, delta, Q0 and F. I've uploaded a video on the finite state machine. You can watch on iTab because you need to understand finite state machine before finite automata. Both have a few same concepts. So we have Q, summation, delta, Q0 and F where Q is a finite non-empty set of states. And summation here is a finite non-empty set of input called input alphabet. Now the delta here is a function which maps Q into summation. We had A for G in the finite state machine. Here we have delta and Q0, right? So delta is equal to Q into summation into Q, right? Q into summation into Q is called a transition function. When we study non-deterministic automata, we need to have the knowledge of the transition diagram. So, what is a transition diagram? We can make a table with the help of a diagram and a diagram with the help of a table. So, if we have this diagram, how do we make a table? So, the same simple concept is here. We will write state, right? We have input here. Input is normally given in 0 and 1. Sometimes some other notation is also given for the input. Okay? We have 2 states here. One is Q0 and another is Q1. 2 states are given to us. So, students, 0 and 1 are the inputs that are given to us, right? Look students, what will come here? We will write 0 and 1. Now look at Q0. Q0 on 0 is coming back to itself. And when is Q01 coming? Q01 is coming when Q0 is going to Q1. Okay students, Q0 is going to Q1 at 1 input, right? On 0 input, it is going to self, and on 1 input, it is going to Q1. Now let's talk about Q1. Where is Q1 going? On 0 input. Q1 is going to Q0 on 0 input, right? And on 1 input, it's going to itself. So it will be Q1 here itself. So this is what we have. Its table is made, correct? Let's move ahead. Today we will talk about types of finite state automata. We have 2 types of automata. First is deterministic finite state automata. The second type is non-deterministic finite state automata. This one here is denoted by DFA and the other one is denoted by NDFA. Now what is DFA? If it is going to a different state on a different input, for example, it is going to Q0 on 0 input and on 1 input, it is going to Q1. So if we have a state like this one, or if it is a transition diagram, then it is DFA, right? Or we call it deterministic finite state automata. If we have the same input that is going to a different state, like what we have here, it is going to Q0 and to Q1 at 0. So this is how we get an DFA. This is the difference between DFA and NDFA. This is what we need to understand. Different input, different state. Same input, different state. So in that case, the difference is this. Same input is going to a different state. So we will get NDFA here. And if it is going to a different state on a different input, then we will call it a DFA, right? So we need to keep this in mind. I tried to tell you this in NDFA. The finite state automata is called non-deterministic finite state automata. If any particular input symbol, the machine can move any combination of the states. Now look, it is going to Q0 at the input of 0 and it is also going to Q3 at 0 input. It is going to different states on the same input, which is known as NDFA. In these type of cases, it would be called NDFA. If by any chance, it goes to Q0 on 0 input and it goes to Q3 on 1 input. It goes to different states on different input, then it is DFA. So this is the difference between the DFA and NDFA. There is one more important thing. Listen to me carefully. Every DFA is NDFA, but the converse may not be true. The converse is not true here. But the questions in the exam will be given to you in NDFA and you will be asked to convert it to DFA. So, such questions are asked in the exam. And that's what we are going to study here. Let's see. But how do you convert it? The question is to convert NDFA to DFA. What do we have here? NDFA. Now, how will you know that this is NDFA? The same input should have a different state. Look here. So, at 0 input, Q0 is going back to itself, and on 1 input, Q0 is going to Q1, right? At 0 input, Q1 is going back to itself and also to Q2. So, it is going to different states on same input. It's going to state 0 and state 2. So, what we have here is a non-deterministic finite automata. And if we create a state table for this, it will give us a better idea. So, this column represents the states. This represents the input. We have 0 and 1 as inputs, right? So, we have input 0 here and input 1 here. Clear? Now, let's understand how to make this table, right? I'll explain it by solving out this table so you can grasp it better. Moving on, students, we will write the states first. We have the states Q0 here, Q1 here and Q2 here. Let's move ahead. Now, look at 0. With input 0, it is going to itself. See where it goes with input 1. It's going to Q1. Now, let's look at Q1. For state Q1 with input 0, it goes to itself and also to state Q2, right? So, here we have Q1 and Q2, right? If we have two states present in the input table, then it is called NDFA. This is an important point to remember. Now, let's analyze input 1. So, what is happening on input 1 here? Q1 is going to itself. What else do we observe with input 1? With input 1, it stays on Q1 only, right? So, it remains on Q1. Moving forward, let's examine Q2. With input 0, Q2 goes to itself. And I believe it is going to itself only. Nothing else is happening there. So, this is Q2. Let's see input 1. With input 1, it is going to itself and also to Q1, right? So, this here will be Q1 and Q2, right? This is called non-deterministic finite automata. Now, how do we convert this into a DFA? There is a way to do it and I will explain it to you right here, okay? So, whenever we encounter such a problem, how do we perform this conversion? That's what I am trying to explain. So, we will make a column for states, a column for input, and we will write 0 and 1 under input. This is a very good concept and it's important to understand it. So, let's continue. First and foremost, we will take the initial state as it is. We don't need to change it. We will write it as it is, okay? Now, here's what we'll do. We need to select one input from these two. But Q0 is already present here. Now, we will consider Q1. Write Q1 here. If Q0 wasn't already there, then we would have taken Q0. Now, let's focus on Q1. What input are we getting for state Q0? Let's see here, okay? What are the input we are getting from Q1? It's Q1 and Q2. So, here we will write Q1 and Q2. So, on Q1, the input on 0 is Q1, Q2. Now, on state Q1, what is the input we are getting at 1? Q1, right? We have already considered Q0 and Q1. Now, we will come here. So, we will take Q1 and Q2 here, right? This is an important thing to remember. Let's move on. Next, what we have here is Q1 and this is Q2, right? Both of their inputs at 0 are Q1, Q2. Look, the input coming here is Q1, Q2. So, ultimately Q1, Q2 will come, right, students? Now, what is the input of 1 on Q1, Q2? The input of Q1, Q2 on Q1 is Q1, Q2. So, ultimately we will write Q1, Q2 here. Now, nothing is left. We have taken Q0, Q1 and we have taken this as well. And lastly, all three of these are same. So, this will become the final state, right? Now, we will make a diagram for this. Now, how will we make the diagram? So, I will make it here so that you can understand things better. We'll write it as a state, right? So, I will make its diagram here. Okay, we have Q0 here, we have Q1 here, and I will write this as Q1, Q2. So, we have Q0 here going to itself. And input 0 is coming here. Q0 is going to Q1 and input 1 is coming here, getting my point in this Q1. Q1 goes to Q2, right? So, we will take this whole thing as one state. We have 0 here, right? Look, Q1 goes to Q1 on input 1. So, it will be a self loop, right? Now, if we talk about Q1, Q2, it is going to Q1, Q2 on input 0, right? Q1, Q2 goes to Q1, Q2 on input 1, right? Students, are you getting my point? Listen, students, what we have here is a DFA. Now, see here, it is not going to different states on same input. because it's going to different states on different inputs. So what we will have here is a DFA. Okay. So in this way, we have converted it into DFA. Clear? So listen, I want to clear this thing about this diagram. You might have this question that, sir, you call this a DFA. It's going to the same state on both 0 and 1 input. We know what is the definition of NDFA. NDFA is defined as having different states for the same input. And DFA is defined as having distinct states for distinct inputs, right? But by chance, if distinct inputs are going to the same state, then it is also a DFA. Just want to clarify so that you can understand that in DFA, different inputs can go to the same state. Okay. It's going to the same state on both input 0 and input 1, right? So this is a DFA and not NDFA. This is what I wanted to clarify. Now, how to convert the following NDFA to DFA? We have this NDFA and we want to convert it into DFA. How will we do that? Firstly, we'll construct a table. We have Q0 and Q1 here. Now, let's focus on input 0. Q0 is going to Q0 and to Q1. So, we'll write this as Q0, Q1. Now, let's move on to the input 1. For input 1, we see Q0 going to Q1. So, we'll write Q1 right here. Next, let's examine Q1. With input 0, Q1 is coming back to itself. And if we talk about input 1, Q1 is going to itself and to Q0 too. So, we'll have both Q1 and Q0. This is NDFA. Did you get it? Our goal now is to convert this NDFA to DFA. How will we convert it? We will make a table now. We will make columns for state and input in it. Okay. Inputs we have here are 0 and 1. Is that clear? This has been given to us. To begin, we directly copy the initial table. There's no need to worry. So, we will have Q0, Q1 and Q1 here. And Q0, Q1 is one single state. Now, we can take any one from these. So, I will take Q0, Q1. Now, students, look at the table at Q0 and Q1. What is the input coming on 0? If we will take both Q0 and Q1 at 0. So, ultimately, the input will be Q0, Q1 only. Therefore, we will write Q0, Q1 in the table, right? Moving on, let's talk about 1. How much input is coming on 1, right? So, how much input is coming on 1? It is Q0, Q1. Look at the table, input coming on 1 is Q0, Q1. We will write Q0, Q1 here. We have already taken Q0 and Q0, Q1. So, now we will take Q1. Now, let's look at Q1. With input 0, we see that Q1 is going to itself. With input 1, it is going to Q0, Q1. We'll write Q0, Q1 here. Now, we've covered all the possible states, Q0, Q0, Q1 and Q1, right? Now, students, as a final step, we will draw its diagram. We have Q0 here, Q0, Q1 here. And here, we have state Q1. We have Q0 here, that is going to Q0, Q1. So, input 0 is here. And state Q0 is going to Q1. Hence, we get input 1 from it. From Q0, Q1 to Q0, Q1, it's going to itself, right? We get input 0 and 1 as Q0, Q1 is going to itself again. Now, you will see what's happening here for the same input. Both 0 and 1 are going to the same state. What we have here is a DFA, right? We need to keep this in mind that in NDFA, the same input should lead to different states. This is not NDFA, right? Now, if we look at Q1, Q1 is going to itself, correct? In this case, Q1 goes to Q0, Q1. Q1 goes to Q0, Q1 and 1 becomes the input. So, this is its DFA. This is how we convert NDFA to DFA. Okay, students? You need to keep this in mind how all three states are the same. This state is the final state. You can represent this in a diagram. Is it clear? Now, let's move ahead. The next thing we need to understand here is the transition table of a FA. You are told to make its transition table. You can make the transition table very easily. We have S0 here and this is S1 here, right? Okay, students? We will take this as S2 and this is S3. Is it clear? You can write them in any order. It's not a problem. Now, S0 is going to S1, right, students? So, S0 is going to S1 and the input here is 0. Now, S0 is going to S2 and the input here is 1. Now, let's look at S1. S1 is going to S3. S1 is going to S3 and the input is 0. The next question is converting NDFA to DFA. Here you are asked to convert NDFA to DFA. Here the input is given in the question as A and B. So we have two inputs given here that are A and B. Okay, students. Now let's look at S0 here. Look at S0 on input A. On input A, S0 is going to itself. So Here it is making a self loop. On input A, it is going here and it is also going here. Okay, students. So S0, it is going to S1. And for input B, look here, we have S0 going here. So this is how we will get S3 on input B here. Now let's analyze S1. In which direction is S1 going? Firstly, it is going to itself on input B and it is also going here to S3. This will be S1 and S3. Look in the table, we get S1, S3 here. So for A, if we look at A, where is A? It is coming here. Here we have S1 that is going to S0 for input A, right? Now let's talk about S2. Let's come to S2. Here it is. Now from S2, do we have any input A? Look, there's no input A. We only have two inputs here, B and B. S2 is going to itself and to S0. So S0, S2 will go here. There's no input for A. Now let's talk about S3. So students, in S3, first of all, S3, both A and B are coming. So let's talk about A. A is going to S1, so S1 will come here. On input A, S0 is also going to S1. You can see that here, right? It's also going to S2. You can see A is going to S2 here and here to all three states. And for B, we only have one input for B here, and that is S1. Okay, students? This is how we'll make a table for it. Now what we will see here is how do we convert this NDFA to DFA. Now look carefully here. I will do this again. Okay? We'll make a column for input here. Sorry, firstly, we will talk about the state, right? We will talk about states. And here we will talk about the input. So this is 0 here. Sorry, we have A and B here. Now we will convert it. Okay? We will convert this. So in DFA, we will write the first one as it is. S0, this we will write as S0, S1, and this will be S3 here. Okay, students? Now listen, we'll take this S0, S1 here, right? Now come to S0, S1. S0 and S1, here we have S0 and S1, and here we have S0. So this S0, S1 will come here. Clear? So this will come to us S0, S1. Now check its input on B. So on S0, S1 for B, the input that is coming is S1, S3, right? So we will write S1, S3 here. Now listen, we have taken this. Now we will take this S3. Clear? Now on S3, look at S3. It's going to S0, S1, S2 on input A. What will it be? It will be S0. S1 and S2 as input here on A. Okay, students? So in S3, our input on B gives us S1 here. Okay, students? Now see, we have taken S0 and S1. Now we'll take S1 and S3. We have S1 and S0 here. So we are getting S0 here and S0, S1, S2 here. So we will write here S0, S1, S2, right? Because S0 is already covered. So we don't need to write it again. Now in S1, S3 on B, input we have on S1, S3 is S1, S3 and S1. So S1 and S3 both are going to be covered, right? So we will write S1, S3. We have already written this and this has also been written. So now we will take this. Okay, students, we'll write S0, S1, S2, right? We will take this here. Is it clear? Let me just increase it a bit so that I can write it here. Okay, I am making the lines longer. Wait. Now see, we have S0, S1, S2. On S0, S1, S2, we are getting S0 and S1 only. Clear? Now see, we don't have anything else. So we will write S0, S1 here. So S0, S1 and S2. For this on B, the input we will have is S0 and S1 and S2 also, and S3 too, right? So here we'll get S0, S1, S2 and S3, right? All three of these will come here, okay? Now look, we have this. Now let's first deal with this S1, right? Then in the end, we will take S0, right? We'll take S1. So in S1, we have 0 here, okay? And here we will write this one as S1, S3, right? So this will come here, right? Only this is left. We will write S0, S1, S2 and S3 here, okay? We will take all the 4 states. So we will have input S0, S1, S2. If we take all 4 states, then we will get S0, S1 and S2. And here we have S0, S1, S2, S3. You need to understand this. We are not getting S3 here. Clear? So we will get only this. You need to pay attention to this. Now let's create a table for it. I think this question will be done after making the table, right? So let's create its table. Okay, students? So how many states are we getting? We have S0. So I will write S0 here. Then S0, S1. Then we will take this S3 here. Okay, students? Then we will write S1, S3 here, right? Then we will write S0, S1, S2 here, okay? Here we will write S1 and lastly we have S0, S1, S2, S3, right? Now start connecting all the states. Let's start with S0. S0 is going to S0, S1 and we will get input A. So S0 here is going to S3, right? Okay. I'll just change the color a little bit. So we have S0 going to S3 like this on B. We have S0, S1 going to itself. So it will be a self loop. So it will be a self loop in the case of A. Okay, students? In this case, and it is going from S0, S1 to S1, S3. We are getting B here. So from S3, we have S0, S1, S2. So from S3, it's going here, right? So this will become A. And S3 to S1, it's going from S3 to S1. So this will become B. Similarly, S1, S3 is going to S0, S1, S2. S1, S3 to S0, S1, S2. Okay, we will get A here. S1, S3 is going to S1, S3 on B. It is a self loop. S0, S1, S2 is going to S0, S1. So S0, S1, S2 is going to S0, S1. So now we are getting A here, right? From S0, S1, S2, it is going to all the 4 states on B. Clear? This is something you need to pay attention to, okay? Next, we have S1 going to S0. So this S1 is going to S0. So it will come here, right? So now we will get A here. Is it clear? Next, S1 is going to S1, S3. So S1 is going to S1, S3. So you'll have to bring it back from here to here. So let me change the color a little bit. So this will come like this from S1 to S1, S3 and it will be B. So you have to construct it like this. Next is S0, S1, S2, S3 going to S0, S1, S2. So this will come here. Is it clear? This will be A here. Okay, students? And S0, S1, S2, S3 is going to itself. So we'll have B here. Got it? So this is how we construct the diagram. And this will become our DFA, right? It's a bit difficult, but you need to understand it. And the final state we will have will be this one. Okay? Got it. The one which covers the maximum states, we call it as the final state. Clear? Let's move ahead. This question is for you. Write its answer in the comment box. I want to tell you that I am uploading lots of videos like these for you. I hope everyone has understood the concept of finite state automata. And you can watch the playlist for other discrete mathematics topics from here. My new channel where I upload videos for CSIR NET, GATE and IIT-JAM exams. You can go and watch it here and subscribe to my channel and follow me on Instagram. Thank you so much everyone. Give the answer of this question in the comments. Thank you.